welcome back after the break. Hopefully you had some nice lunch and some coffee so you wouldn't get sleepy. Yeah, we are about to begin. For all those watching us online, I can see your questions on Pine. Sometimes there is just not enough time to ask all these questions, but still write those down. And I think Maciej here is going to end a little bit earlier, so we will have time for questions and answers. And on the stage you already can see Maciej Rząsa. He's a software engineer specializing in Ruby with over 10 years of professional experience in various domains, that is TV, recycling, travel, translations. He's interested in text processing, distributed systems, and writing software that matters. He's a knowledge sharing advocate, co-organizer of Ruby user group and Railgirls Restov. Occasionally he is a speaker at technical conferences and meetups, and after work he's a lecturer and instructor at University of Technology at Restov. Is the right way to pronounce it? Never mind. Thanks, that's a good answer. API optimization tail, monitor, fix, and deploy it on Friday. And Maciej Rząsa. Let's welcome with a round of applause.
It's okay now. And now to my packet. Is the sound okay? Let's get it started. Hello, I'm Maciej Rząsa and I come from Rzeszów, Poland. And let's begin. It doesn't work again. Okay. It was Friday afternoon when I saw a green build on Jenkins. This green build contained my changes, and I knew very well that I need to see those changes on production before the weekend to test something. At the same time, I had very strong gut feeling that it was a trap. And it wasn't a mere superstition about deploys, Fridays, and kittens, right? Because in the very same project a couple of weeks before, I did a deploy, I broke production, and I had to stay late after work to fix it. And you know, after work, I have better things to do than fixing broken production. Really, I do. So, I was sitting there Friday afternoon, 4 p.m., contemplating whether to deploy or not. I'm just kidding, I was typing like furiously to our deploy bot to see the deploy before I leave work for the weekend. That's strange, right? Why was it so important to see it before the weekend? What gave me the confidence to deploy on Friday? And last but not least, what was I thinking? Testing on production, right? I'll answer all those questions. But before that, we need to take a few steps back. I work for TopTal. TopTal, you can think of it as a complex job board on steroid. We connect the best freelancers in the world with the clients that need freelance work, and we are in between. And in the heart of our ecosystem is the TopTal platform. It's our main service. It serves most of our requests. And with million lines of code and hundreds of engineers developing it daily, it's huge. It's a monolith. And yeah, it's majestic. And we are on the quest to modularize this monolith. As probably all of you are, yeah? We have a big monolith, we want to modularize it. And one of the approaches to modularize was to introduce service-oriented architecture. And I was on the bleeding edge of this initiative. I was very happy there. I was in the project called Billing Extraction. We were aiming to take all the code that's related to billing domain that was scattered across the domain, across the platform, across our main service, and put it to a separate service deployed as a billing service. It was a wonderful undertaking, and the easiest way to do it was to make a huge code freeze, put the code from here to there, and then deploy everything, and 2 years later we can unfreeze the code, right? Of course, it's not possible to freeze the code for that long, and nobody expected that it was 2 years. Actually, it wasn't. But yeah, we had to do it without any disruption, either to our users, clients and talents and our staff, or to our fellow developers that were constantly changing, developing our platform. So we decided to do it in a safe, incremental manner. At first, we put all the billing code to a separate module, and all the code that was supposed to be extracted, we put it in the separate module that was called, in the Rails word, this kind of module is called engine. And we were calling this with direct calls, with normal method calls. That was the first step. And the second step was to test if the external API works correctly. So it was still, the billing code was still in the same process, but we were doing external calls. The asynchronous API was over Kafka. It's very, very interesting, but I won't talk about this because I'll be focusing on more boring stuff on the HTTP interface, on the synchronous interface. To make it safe, we exposed the REST API from the billing engine, and to make it safe, we did two important features. The first one was a feature flag. So we were able to switch on the instant the traffic between the direct calls and the HTTP calls. So we were able to enable HTTP calls for just 10% of the traffic, and we were able to do it on method by method basis. So we were able to roll out the features safely. And in the unlikely event of rolling out a faulty feature, we had a fallback. So if an HTTP call failed, we were falling back to the direct call. So for the user, it was slower, but it was slow correct. So what was the extraction about? That was the starting point. We had two models. It's Ruby code, but Ruby is like English, so everybody understands it, right? We had two models that were that had ORM associations in database associations before the extraction and after the extraction. Product stayed in the platform, and if you wanted to access billing records from product, we were calling billing query service to fetch the products from the external service, from the billing service, and we had this data object of billing records that could also initialize the back reference to the product. So instead of having two models in the ORM, we had one model in the ORM, and the other object was just a data object. It was active, but it was just a data object. So we started with the safe deployment approach. Besides having the CI checks before deployment, before having easy and reliable rollback that will help us in the next part of the presentation, we also had a safe environment with a fallback, so that if something goes wrong, nobody notices, only us. And we have the feature flags so that we can easily switch on and off the experimental features. So we deployed this changed code, this extracted code in the same process, and we enabled it for a small percentage of the traffic, and we monitored, and yeah, we failed miserably. Let's again. No, again, it was terrible. The performance was abysmal. Even for a small fraction of the traffic, it was unbearable. So we switched it off, and we knew that we have to change it. We have to optimize it. And I think that, yeah, you are engineers. We all love that kind of work. Yeah, we don't do new features, we optimize. So let's dive into New Relic or Datadog or anything like this. Identify slow queries and then optimize database calls, and everything is great, right? We see the numbers. Everything is awesome. And that's not what happened again. We decided that we need something bigger. We need a bigger change here. That the REST like REST API, is no-go for us. So in the middle of this big migration of switching, of extracting a service, we did a small migration of switching between REST and GraphQL. And we did this migration again in a safe manner. We added another feature flag to switch between REST and GraphQL, because REST was safe. REST was no, it wasn't battle tested, but at least it was correct, even though it was slow. and we were switching between old, slow but correct solution to new, even more experimental solution that was GraphQL, and that was supposed to be fast. And we also added fallback from GraphQL, so that if anything goes wrong, we fall back to the direct call. So again, it was supposed to be a safe change. And we did one more thing. We enhanced greatly our monitoring. We enhanced observability in this optimization. We were logging metadata for every request sent to the billing service. We were logging method name that was called in the query service, its arguments, the stack trace, elapsed time, and if needed, the error. So that having obfuscated production dump locally, we were able to reproduce the slow calls to the point, because with the stack trace, we knew what were the hotspots in the platform calling the billing service frequently. With method name and arguments, we were able to reproduce this exact call locally and measure it and understand what's slow. So the feedback loop was tightened drastically. We were able to work very fast because of that. So to sum up, before we even started optimization, we stood on two strong pillars. Strong deployment practices and very precise monitoring, and then we were able to start actually optimizing. The most important problem that we were dealing with were pages or background jobs that were making thousands of requests to the billing service. We were DOSing ourselves by doing so. How we approached this, it was very innocent, you know. When we were looking at this, when we were looking on this job, it's great. We were selecting some products, right? It's visible. We're selecting some products from the database. Then in batches, like hundreds, we are fetching them in hundreds from the database. We were calling some business logic. Everything is right, okay? But when we look at the inside, it's again quite okay. It's just product billing records do something, right? But if you remember, product billing records is calling the external service. So every time we are inside this loop, we are calling the external service. It could be hundreds or thousands of calls. So for sure, it's very slow, right? What we did, we decided that the active object approach that was very natural for us Rubists is not a good idea, and that we should move data fetching one level up. And we moved it to the job code. So besides fetching products in batches, we were also caching billing records. And what did it mean to cache billing records for a batch of products? We were doing three things. First of all, we were fetching billing records for all the products. For it was just one external call. Then we were indexing it by the product identifier. And then finally, we were assigning them to the product. So instead of doing thousands of calls, we were doing just a couple of calls, and the performance improved dramatically. By the way, if you think it looks like a hash join from the database, you are right, it's something similar. We had to re-implement an algorithm known from the databases inside our application before we were splitting our data sources. So what we learned here, by the way, if you are talking about GraphQL, about hash joins, best regards to the creator of MySQL, because MySQL has hash joins since a couple years ago, even MySQL, right? So what to do with the flood of requests with something that resembles N+1 problem, the same as with ORM databases: preload, cache, and join to have the correct data model in your application. What was next? We had this N+1, this request flood, but then we had another problem. We had one specific field that was frequently from billing that was frequently needed in platform. And it wasn't that a single job or a single page was fetching this field repeatedly. We just need it very often in various jobs and and on various pages. So caching was out of the question. And we decided that we could do something smart. If we need it frequently, we should cache it, but in a smart way. So every time this field changes in billing, let's send update on Kafka. Then let's build a read model on the platform side, or the monolith side, and then just use this read model. And we also need some data backfilling. It's a smart plan, right? I was very happy because that's why I was implementing this, because it was interesting. And when I started on a daily, Samuel approached me. Samuel was our colleague that had very vast billing knowledge, and he said, maybe we don't need Kafka, and I was a bit angry. We don't need Kafka at all. I was very angry. We can use local data. Local data, so boring. But okay, let's give it a try. So we found this data in the local database, and we need to correlate data from this database and that database. So we spent a day writing that huge SQL queries and talking to people, to business people, and to billing feature team, billing product team. And after 2 or 3 days, we decided that yes, we have the same data in the database, in the local database, and we don't need to do anything. We just need to replace one query with this external query with a database query. And that was awesome, because instead of spending more than a week and writing hundreds of lines of code and using Kafka and then maintaining it, we spent 3 days and we changed a single line of code. That was very awesome solution, even though it was boring, and it really worked. The request stopped then. So what we learned here is that while technical ability could help us in winning the performance battles, the domain knowledge can help us avoid those battles at all. And it's even better. And then we solved the n+1 problem. We used that local data for this field that was frequently used. But then we realized that from time to time we have very slow queries. A single query is very, very, very slow. Why was that? That our REST API was meant to be simple and generic. Sorry. And generic API needs to return everything. So it was returning everything. It was about 40 fields in the response and 3 or 4 associations, and in those associations there could be hundreds of other records. It was a lot, right? And to make it worse, it was filtered on the client side. So we were fetching data that wasn't really needed. And that was the moment when the decision to switch to GraphQL really paid off. Because after implementing on the server side, on the billing side, the GraphQL types and resolvers, we were able to easily define which fields are needed, just 4 of them. We were able to easily define server-side filters and just return the data that was required. It was really great, and I must confess it was a very good experience for me. I was doing this task, and at this time I was accustomed to this habit, to this routine that we start a new task, we check the stats in our monitoring, then we reproduce it locally, we fix it, we deploy to production, enable the feature flag, and we check that it's faster. It was very rewarding because the feedback loop was short, and it was the same in this case. I created a fix, I deployed to production, I enabled it. I enabled the feature flag, and I was waiting to see that it's really faster. By the way, do you remember what was the hottest day of the summer of 2012? That first summer after the first COVID wave, when we all rushed to pubs and vacation resorts and we believed that the plague was over. I remember it vividly. It was Tuesday, 28th of July. It was the day when I deployed this. And I deployed it, and I waited for the stats, and I was checking Slack, and somebody wrote, our background workers consumes a lot of memory on staging. And I thought, oh, poor infra guys, they will have to deal with it. Bad day. Somebody said, it's impossible to deploy to staging. Somebody broke the build. I thought, oh, nasty guys, somebody forced matched. They'll have to fix it. And then somebody told me in private, it was your build that broke production, that broke staging. And I said, no. But I started checking it, right? It was a good way to do it. And then somebody from the business side came and said, platform is kind of slow. And I thought, interesting. And then somebody said, when Americans woke up, platform is down. And I knew it was my build that broke the platform. I felt cold sweat on my back. It was the hottest day of that summer. How bad it was? It was terrible. Memory consumption was over 10 times bigger than usual, CPU utilization the same, and to make it even worse, Postgres queries, a single Postgres query was taking about a minute. Have you seen online transaction processing Postgres query taking a minute? Yeah, that's a bad sign, right? That's a very bad sign. Yeah, I was very stressed. But then, two good things happened. Before I even realized, before I even reacted, the infra happened. The infra guys came, they noticed, okay, this build is faulty, let's revert it. And before I did anything, they were starting reverting the build. So when I came to help, it was actually happening, and all they asked me was to fix it on master. And then I reverted my changes on master. We were waiting for the green build. Of course, I had to stay late after work. And then the master was green, and I came home. That was good. And another good thing that happened was my manager. He approached me the next morning, asked me if I need any help. Yeah, a manager approaching after breaking production, a kind of stressful, right? Should I go to check then for a new job, right? And then he said another thing. Thank you, good job. Jose, are you sure you're telling it to me? I broke production. Yeah, it's okay. What? It's okay. You broke production. We are in a fast-paced environment. It happens. But then you stayed, you fixed it, and everything is correct. Good job. Thank you. And it was very important. 10 minutes. It was very important to me because it showed me that it was the part of this safe deployment process. I can make a mistake as long as I follow up to fix it. It's okay. It was very important. What was wrong here? So I did a bit of refactoring on the safe, on the REST branch, and I decided that we enhance the sanitization of the parameters. And I was sanitizing overly eager. So I sanitized too much. And if somebody leaving just product identifiers, if somebody asked for records for a client, there was no filter, and if there was no filter, nothing was added to the select, to the database, so we were fetching all the billing records with all the associations and all of them, their associations, probably hundreds of thousands of records sent from the database, instantiated in the application, and I hope it never reached the place to serialize it, push it through the network. It was terrible. So the fix was simple. We fixed the sanitization, and we also decided that if there are no filters, we return nothing. And how come it slipped through our CI/CD pipeline? That's a very good question. First thing, GraphQL was experimental, REST was safe. So we switched our integration tests to test only the GraphQL branch because of the cost of those tests. Of course, I had a unit test for this sanitization, but in the test I was using that parameter that was correct, because who tests all the parameters, right? And then we had the feature flag, and when I realized that something is odd on production, I switched back to the safe REST branch, and this safe REST branch was faulty. So it didn't work. So I managed to bypass all our checks and break the production. Yeah. I would say I'm proud of myself, but I'm not. And yeah, the good thing is that the optimization really worked. It was the spiky, all those spikes were before those big requests and unpredictable response times, and that's the result. It's much better, right? It's more predictable, it's faster. So query customization and underfetching and filtering on the server side was something that we learned from technical side here. But there was even more important organizational lesson. We have a special section in our pull request template asking how to test. And I answered here, trust the automated tests. And it was a mistake, because I should have prepared a simple manual test, even in the Rails console, even just a programmer's test, because I believe that if I did this test or my colleagues did this test, we would have noticed that the response time is odd, that the logs look strange. We could have acted and we could have avoided all of this, but we didn't. So yeah, always test manually. That was my lesson. And you know, if it were a novel or a film, I would have finished on this high note, right? Dramatic task. Final boss killed, final castle conquered, we are getting back home. But it was a project, and you know that projects are anticlimactic, right? We do something awesome and then we do another thing. So there was another thing. We noticed that even after fixing everything, regularly Sunday evening, we had some requests dropped on the reverse proxy on billing. We saw 4 to 9 HTTP errors. We noticed that we were scheduling reminders to our talents at this time. And when we schedule them, we ask a lot of questions. We send a lot of requests to billing. So yeah, we did the old trick: cache, preload cache and index. And we tried it. We waited for Sunday and Monday morning. We saw the same errors. Why? Because we weren't only scheduling those, but we were also sending those reminders. And before sending them, we also had to check something on billing. We thought it's not a problem because the reminders were localized to talents' time zones. But we forgot that most of our talent, no, maybe not most, a quarter of our talents live in a single time zone, so they are not scattered evenly across the globe. So the solution was, the obvious solution was to ask them to move, but apparently it was out of the question, so we had to find a technical solution. And sorry, what we did was we added a small jitter. So instead of sending everything at 5 p.m. sharp, we decided to randomly send it a minute before and a minute after, and we deployed, waited for Sunday, and on Monday morning we saw the same error. What was the issue? We forgot about one reminder, so we fixed it and we deployed Sunday evening, right? Monday morning, the same issue. What was the problem now? So we were using Sidekick. Sidekick is an awesome background job processor for Ruby, but at least our installation had 15 seconds resolution in polling the queue. So even though we were scheduling something with the second resolution, and we were hoping to have 120 big buckets. We had only 8 small buckets. We had only 8 big buckets, and it was too much. So yeah, we just used the proper way. We just used sidekick limiter that was implementing the proper way of bucketing, and this time it worked after 4 weeks of struggle. And you know, it was during this task when I saw a green build on Friday afternoon, and I decided I must deploy it before the weekend. And I need to confess to you that I did it twice. On the very beginning of this project, on this optimization task, and on the very end. And I hope that you now understand why I was doing so, and why I was so confident that even that I can deploy on Friday, and it's all safe. And what we learned here, we noticed some patterns, some optimization patterns during this project. We noticed that there are some ways of optimizing how we use the external service. We can preload the avoid n+1 queries. We should filter on the server side, use local data if needed. We should fetch only the fields that are required, and we shouldn't send requests in big spikes. We should spread the load. But when you take a look at this list, I think it looks familiar. It's nothing new, right? So preloading to avoid n+1, it's every ORM, right? We did it in a new context, in the context of GraphQL client. With server-side filtering, it's also always, do we want to filter on the database side or on the application side? And then using local data is like browser networking performance one-on-one. Don't use the data that you already have. And the fetching is so embedded in SQL that we don't even have a name for this, right? And even spreading the load, I read about this on high scalability blog 10 years ago about YouTube performance. So those were known patterns, but they were known in a different context. Yeah, we have to apply them in our context. The question is, why didn't we do it from the start? Why didn't we do it right from the beginning? The general question is that in the hindsight, everything is obvious. In the foresight, it's not. But the more precise question is threefold. It's about simplicity, learning, and trade-offs. Simplicity, we started with a simple and boring solution. We had old, boring REST. We had a small surface API. And only then, when we realized it's a no-go, we decided to improve it, to migrate to something fancy like GraphQL, to make the API more sophisticated. Learning, even after that, we noticed that when you extract something, especially to a separate service, you cut a lot of ties in the code, right? And when you cut those ties, you may happen to cut the ties that are meant for performance, like preloading. And you could not realize that you did this because you make changes here and the performance issue is there. And we learned that the only way to really check if the performance is okay is to apply the traffic of the production shape to your architecture, to your applications. Remember the problem with 492? We weren't able to reproduce it locally because it happened only because of the Nginx queue. So we had to check it on production. And the last answer is trade-offs, as always. For instance, between simplicity and sophistication, between simplicity and performance, but also there were trades-offs that were domain-related. When we were implementing the jitter for the notifications, a colleague from the billing feature team approached us and said that they would prefer to send all the notifications at 5 p.m. sharp without any jitter. Jitter is a bad thing here. And we had to explain them that it's no longer possible and we just need this jitter. It was a trade-off between sending everything as the product mandated and doing what is possible within our boundaries. So yeah, in hindsight, everything is obvious, but the learning is very often bumpy. So I shared our learnings, I shared our successes, but always also our mistakes, so that you don't have to, you can follow our successes and you don't have to repeat our mistakes. Instead, you can go back to your project and make your own mistakes. But when you do, please return to this conference and return to your local meetup and tell us about them, because that's how we all learn. And if you wonder if you could really do it, if it's safe to do it, I can propose you a simple test, simple mental experiment. Think if you can deploy the code in your project on Friday. Thank you. I'll answer all the questions now.
So when you do GraphQL, right, there's one problem because you don't know what the client is requesting. So for instance, if the client is requesting a complicated graph,
Mm-hmm.
complex graph, that means that you're probably using the batch data loaders, right? Which means multiple database requests.
The question is that, let me repeat this and check if I understand. When a comment, when you use GraphQL and the query graph is complex, we need to make several database calls.
Usually because
Yeah.
you don't know what the client is going to request, right?
Mm-hmm.
At the same time, when you use REST, for the most part, well, you know what the client is requesting, right? So you can
Mm-hmm.
minimize the number of database calls. So, like you can optimize, right, very
Mm-hmm.
specific queries and so on. So in your case, you have both. You have both of those two words. Well,
Mm-hmm.
you have GraphQL and you have REST. So are you trying to, like, what's the approach? Are you trying to use them these days in production in parallel, or you just fully migrated from one to another?
With the question is if we keep using REST and GraphQL for their best way of using. So we migrated fully to the GraphQL, and of course the problem that you described, that the client can ask for whatever, and then it's hard to optimize the queries. It's real when you don't control the client. And in our case, we were controlling the client, and we were crafting carefully those queries on the client side. And because of this, we were able to optimize them well on the server side. So it wasn't the typical usage of GraphQL, because we had certain assumptions about the queries that are sent, but it was working well in our case because we had only this one client, and we were able to optimize. We also use GraphQL in other cases, like for the front ends, for like the public API. And in this case, we don't fully control the client, of course, or we don't want to pretend that we control it. And then, yeah, we use batch loadings, and we are aware that we may make more database queries that we would do in REST, but still. GraphQL is so good for the organizational perspective to define a stable API that it really pays off. Please.
Hi, brilliant talk, thank you.
Think.
So, from hindsight, do you think that having more test coverage, be it like unit test or integration test or end-to-end test, that may have prevented breaking frauds and
The question is if better code coverage would help us to prevent breaking the production. The answer is I'm not certain. Of course, in the hindsight, if we had this single test, it would have helped, but it's also always a trade-off. I think that the better technique would be to use randomized tests with predictable seed. It's possible with our tooling. And even just run a single test, but switch the fields in the sanitization to be sure that they are all covered. About the integration tests, running them for both branches would be too expensive, because the cost of running them on the cloud is prohibitive, and we just run it on the one side. So in this case, I should have been more cautious when changing the code that was not covered by the integration tests. We did this. We made this decision because we, of course, as in any project, we had a deadline and we had to act quickly. So that's why we switched it. What would have helped here? Probably if we were able to run the production stack locally. Like, you know, if you had good fancy Kubernetes stack, you theoretically can run it locally and then apply the production traffic and check if it works. But that's something that didn't happen. It's the investment in the infrastructure in this case, such an infrastructure in this case wouldn't pay off. So we didn't have it. So to answer this, yeah, we should have more unit tests in this case, but it's hard to predict when you skip something, right? Yeah, please.
Just you know, continuation of this one. So you said like it's expensive to run the production traffic locally, right? But have you also considered to send some shadow traffic to this new API? So for example, let's say you already have your GraphQL API ready now.
Mm-hmm.
Just before you bring it to production, right? You basically start sending your real traffic, production traffic. So only this one. So it's and then
Mm-hmm.
you could just quickly intercept it like it's
Yeah.
time, and then you could already have metrics before, which you could already give some insights before even you make this.
Mm-hmm. The question is if we were considering to send shadow traffic to the new API before rolling it out to production. We haven't. That's a very good idea. We wanted to do something later. We were considering switching the database and we wanted to test the performance. So the first idea was to do exactly what you said, send the shadow traffic to one instance that's using this new database. But then we realized that it would be great if we had only one service, but then this one instance would have to communicate with all the other services. So we would have needed a whole stack that's receiving the shadowing traffic. And I hope that we will reach the point when it's possible, but right now it's not. Any questions? So thank you. I will be available at the conference for all 3 days. I'll be happy to chat.